Hello students. So we are doing complex numbers and quadratic equations. Today we are going to see Argand plane and polar representation. Okay, so we have done this earlier also, that is how a complex number is represented using a graph. So the way we represent using coordinate axis, that is x and y axis, we have here x-axis, that is the real axis, and y-axis as the imaginary axis, right? And this plane is called a complex plane or a Argand plane. Okay, plane. So here, if you take a number, say point x comma y, okay, p, and this is origin. So this is a representation of the number x plus iy, right? So the distance from O to P is our modulus, that is root of x square plus y square. That is, we use distance formula for this. Okay, so this is mod z. So this is theta, is x, and this distance is y. Okay. So what is tan of theta? Tan of theta is opposite upon adjacent. Opposite is y, adjacent is x. So if you want to find theta, how to use this tan inverse of y by x. Okay, then how we write x, that is, this is our adjacent, right? So we have to make use of cos theta. Cos theta is adjacent upon hypotenuse, it is mod z, modulus. Okay, yeah, and here we write that mod z as r. Okay, so taking r here, our axis r cos theta. Okay. What about sine? Sine theta is opposite on r. So y is r sine theta. Okay. So we can write this r root of x square plus y square. Now this is our polar representation of a complex number. Okay, and this length is taken to be r, right? And this is the angle theta. This is our r. So the real numbers r theta are called the polar coordinates of the point P. Okay, r comma theta. These are the polar coordinates. So x, we write it in terms of r and theta, that is x equal to r cos theta, and sine y is equal to r sine theta. So our z becomes, z is x plus iy. So in place of x, you have to write r cos theta, and in place of y, you have to write r sine theta. So our z is r, you can take common, cos theta plus I sine theta. Okay, this is the polar form of the complex number. This is the polar form of the complex number, where r is root of x square plus y square, that is modulus. And theta is the argument or the amplitude of z. Okay, and theta is called the argument z. So this is given by, so the value of theta lies between 0 and 2 pi, right? If we take principal argument, is the value of theta between positive pi and negative pi. Okay, and this is represented by, suppose this is theta, this is your x comma y. Okay, here minus x comma y, both are minus, and here x comma minus. Okay, this is theta, this is pi minus theta, this is minus of pi minus theta, and this is minus theta. Okay, so we'll solve examples. The value of theta such that minus pi less than theta less than or equal to pi is called a principal argument of z, and it is represented denoted by arg of z unless specified otherwise. Okay. Here are some graphs they have shown. Okay. This is for 0 to 2 pi. This is theta, and this is for minus pi to pi. Positive is there and this is negative. Okay, we are measuring theta from this, that is negative angle. This is positive. Okay, let's solve some examples so that you can understand it better. So represent the complex number z 1 plus I root 13 root 3 in the polar form. Okay, so if I compare this with r cos theta plus I r sin theta, right? Okay, r you can find, that is mod z root of x square plus y square. So 1 square plus 3 square, which is root 10. This is your r. Okay. X is r cos theta and y is r sin theta. Okay. R is root 10. This is root 3 square. So it will be 3, sorry. 4, 2 it is. Okay. Okay. So cos theta is, we have to find value of theta, right? R is 2 and x is 1, right? So cos theta is 1 upon 2 and sin theta y is root 3 by 2. Okay. So we know the values for which cos theta is half, that is 60, right? So the theta is 60, that is pi by 3. So our polar representation is Z equal to R is 2, cos theta is 2, you can write outside. So cos pi by 3 is I sin pi by 3. Okay, so this is the polar representation. Next question. Question 2. Convert the complex number minus 16 upon 1 plus I root 3. Okay, you have to convert this into polar form. First you have to convert it into a plus ib form. So take the conjugate and multiply. One minus 3i square. So 3, 4. This becomes 4. 4, 4 is 16. So minus 4 plus I root 3. Okay. So this is your z. X is r cos theta. Y is r sin theta. This is of the form x plus iy. X is minus 4. Y is root 3. You have to find r. Root of x square 16 plus 3 root 19. Right? Some mistake I have done. This is 4 minus 4 root 3. Sorry. So this will be 16 into 3. 64. So this is 8. R is 8. Okay. So cos theta is minus half and sin theta is root 3 by 2. Okay. This is actually a 60 degree, but here cos is negative. Okay. So using the quadrant form, sin is positive but cos is negative. Sin is positive in the second quadrant. So this is in the second quadrant. So we have to write it pi minus pi by 3 because here we take theta, here we take pi minus theta, here we take minus of pi minus theta, and here we take minus theta, right? To find a principal argument. So this is pi minus theta. Theta we have got pi by 3. So our value is pi minus pi by 3, which is 3 pi minus pi by 3. So this is 2 pi by 3. Okay. So our polar form becomes z equal to r is 8 cos 2 pi by 3 plus I sin 2 pi by 3. Okay. root z equal to minus root 3 plus I. So first you find out r. 3 plus 1. So this is 4, 2. Okay. Cos theta is x upon r. X is minus root 3 upon 2. Then sin theta is y upon r. Y is 2 or y is 1. Okay. We know the values, that is 1 by 2 is, this is 30 degree. Okay. But cos is negative. Okay. So we have got theta as 30 degree, but cos is negative. So principal argument is, this is in the second quadrant, because cos is negative, sin is positive. Second quadrant, it is pi minus theta. So you have to do pi minus pi by 6. Okay, so this is pi by 6. Okay, so you can write the polar form as r is to cos theta minus cos of pi by 6 plus I sin pi by 6. Sin pi by 6. Okay. Let's solve exercise 5.2. Okay. Exercise 5.2. First question. You have to find the modulus and arguments of each of the complex numbers. Okay. So it is given -1 minus I root 3. So mod of this is root of x square minus 1 square 1 minus root 3 square is 3. So this is root 4, which is 2. This is modulus. Okay. Second is you have to find the arguments. That is theta you have to find. Okay. Principal value. So our cos theta is x upon r. This is r. X is -1, r is 2. Sin theta y upon r, y is minus root 3 upon 2. Okay. We know the values. This is cos is half, then it is 60 degree, pi by 3. Okay. So argument of z is, and both are negative in the third quadrant. In third quadrant we take minus of pi minus theta. Correct. So minus of pi minus pi by 6, pi by 3. This is minus of 3 pi minus pi, 2 pi. So minus 2 pi by 3 is the argument of z. Okay. Next is same. You have to find mod and argument. Z equal to minus root 3 plus I. This we have done, I think. Still I'll do it again. Mod z, which is r. 3 plus 1. Again, this is 2 cos theta minus root 3 by 2 sin theta 1 upon 2. Cos is negative, sin is positive. This falls in the second quadrant. Second quadrant, it is pi minus theta. So arg of z, pi minus theta is pi by 6. This is 30 degree. So 5 pi by 6. Okay. Next is 1 minus I. You have to convert each of the complex numbers in the polar form. So same steps you have to take. That is, you have to find arg of z and then you have to write the polar form. 1 minus r of z 1 plus 1 root 2 cos theta x upon r sin theta y upon r. This is 45, that is pi by 4. And one is positive, one is negative. Sine is negative and cos is positive. So this is in the fourth quadrant, correct? Fourth quadrant, it is minus theta. So arc of z is minus of theta, which is minus pi by 4. Okay. So polar form is 2 cos of minus pi by 4 plus I sine of minus pi. This is the polar form. Next one, minus 1 plus I. This is almost same. Mod z is same, root 2. Cos theta minus 1 upon root 2. Sin theta 1 upon root 2. Again pi by 4. Cos is negative, sin is positive. Second quadrant. Second quadrant, it is pi minus theta. So arg of z is pi minus pi by 4. So it is 3 pi by 4. Polar form, cos of 3 pi by 4 plus I sine of 3 pi by 4. Okay. Fifth one, minus 1 minus I. Again the mod is same, root 2. Cos theta minus 1 upon root 2. Sin theta minus 1 upon root 2. Both are negative. Both are negative in the third quadrant. Third quadrant, it is minus of pi minus theta. Again pi by 4. Arg of z is minus of pi minus pi by 4. So this is minus 3 pi by 4. Okay, so z is cos minus 3 pi by 4 plus I sine minus 3 pi by 4. Okay. Sixth question, minus 3. Minus 3 means this is 0 I. Okay. Mod z, which is r root 9, 3 cos theta minus 3 upon 3. So this is 1 minus 1 sin theta 0. 0, 0, 1, 0. 0 degree pi. This is pi. Okay. Yeah, pi. Directly you can write. Theta is pi. So that is equal to cos pi plus I sin pi. Seventh one, mod z 4, 2 cos theta sin theta. Both are positive in the first quadrant. This is 30 degree, pi by 3. Okay, last one. I. Okay. So this is 0 plus I. 1. Cos theta it is 0. Sin theta it is 1. Okay. 0, 1, 0, 0 degree. This is 90 degree. So pi by 2. That is 1 cos pi by 2 plus I sin pi by 2. Okay, this is the polar form.